Hello guys, welcome to my YouTube channel. Today we will discuss about unconstant optimization using graphical method. In constant optimization, we can define these are linear programming problem whose objective function and constant are in linear type. Here in the constant optimization of graphical method, using graphical method, in this concept, here we in the question given that objective function, that is z, and constant g of x, which are on linear type. Linear type means, for example, here 2x plus 5 equals to 0 is a polynomial, that is linear polynomial because its degree is 1. So it is known as linear type or linear equation. Here in graphical method, you have some steps to be followed to solve the problem related to this constant optimization concept. Here in the first step, you have to write function with given constant. Here in the problem, functions and given constant given are there, so we have to first write that given function z or f of x and the given constants. In the second step, we have to write given constant in equality types. Here most of the constant in the problem given in inequality types, so we have to convert in this in equality type, inequality to equality type. In step 3, we have to find the extreme points using the constant. I will explain in the problem how to convert the constant equality to inequality to equality type, and how to find extreme point from constant. In constant, we have to place 0 at x1 to find x2 value, and again place 0 at x2 to find x1 value for all given constant. This also I will explain in the problem to you people. Here step 4. In step 4, we have to plot the graph using extreme points. The extreme points which are obtained from the all constants have to be plotted in the graph using these extreme points. After that, plotting the extreme points, we have to attaches the lines, extreme point, and extend the lines. Then you have to denote the intersect point, which are lines. For example, it is a graph. Here this line and this line intersecting, you have to denote like this intersecting point. In the 6th step, depending on constant condition, we take intersect point, because here this also I will explain you how to take. But here, if in the graph we have so many lines intersect point like this is the intersect point, you can't denote all the points now. So using the constant condition, we take the intersect points. For example, if the intersect point constants are in less than or greater than type, less than or equal to type, we have to take nearer points, and if the constant are greater than or equal to type, we have to take far points. This also I will explain in the problem. Here in step 7, obtained points are substituted in the function f of x. If we are taking by depending upon the constant condition, we take the nearer points and farther points. These nearer points we have to substitute in the given objective function f of x or z. And finally, the last step is, depending on given question, we take the z value. If the given question is maximum, we have to take the least value of z. Here, if given question is maximum, we have to take least value of z. If given question is minimum, we have to take large value of z. These are the all steps to solve the constant optimization problem using graphical method. Let us do an example problem. Here given question is, determine maximum and minimum of z equals to 2x1 plus x2 subjected to the constants are x1 plus 2x2 less than or equals to 10, x1 plus x2 less than or equals to 6, x1 minus x2 less than or equals to 2, and last one is x1 minus 2x2 less than or equals to 1. Let us start the problem. Here in the step 1 we know that what the step 1, write the objective function and constraints. Given objective function and constraint, that is z equals to objective function equals to 2x1 plus x2, and constraints are x1 plus 2x2 less than or equals to 10. This is equation 1. And x1 plus x2 less than or equals to 6. This is equation 2. x1 minus x2 less than or equals to 2. This is equation 3. x1 minus 2x2 less than or equals to 1. This is equation 4. This is the step 1. In the next step, that is step 2, we have to do the inequality. These are the inequality constraints. We have to convert it into inequality constraints. How to be constraints changes to equality type, that is like this. Here x1 plus 2x2 equals to 10, equation 1. x1 plus x2 equals to 6, x1 minus x2 equals to 2, equation 3. x1 minus 2x2 equals to 1. This is equation 4. This is the second step. In the third step, we have to obtain the extreme points. We have to obtain extreme points here. Extreme points. First of all, take first equation, that is x1 plus 2x2 equals to 10. Here, first of all, we have to place in x1 0. That is 0 plus 2x2 equals to 10. x2 equals to 2 1s 2 5. That is we get x2 value is 5. And here x1 plus 2x2 equals to 10. In first one we substitute 0 in x place. Now here we have to substitute 0 at x2 place. That is x1 plus 2 of 0 equals to 10. x1 equals to 10. So it is a point a of x1 comma x2 equals to what value? A of 10 comma 5. This is the first point, extreme point first. It is from equation 1. From equation 2, that is equation 2 is x1 plus x2 equals to 6, placing 0 here, plus x2 equals to 6. Now x1 plus x2 equals to 6. Here x1 plus 0 equals to 6. x1 equals to 6. That is b of x1 comma x2 equals to b of 6 comma 6. It is from second extreme point. It is from equation 2. From equation 3, x1 minus x2 equals to 2, 0 minus x2 equals to 2, x2 equals to minus 2, and x1 minus x2 equals to 2, x1 minus 0 equals to 2, x1 equals to 2. C of x1 comma x2 equals to C of 2 comma minus 2. It is a third extreme point from equation 3. From equation 4, that is x1 comma 2x2 equals to 1, 0 minus 2x2 equals to 1, x2 equals to minus 1 by 2, that is x2 equals to minus 0.5. And from x1 minus 2x2 equals to 1, x1 equals to 1. That is d of x1 comma x2 equals to d of x1 comma x2 equals to 1 comma minus 0.5. These are the all extreme points from equation 1, equation 2, equation 3 and equation 4. You have to denote these all extreme points in the graph here, in this graph. Now take it is a graph. Here take x-axis and y-axis. Take here x, here x dash, here y, here y dash. Here first of all we have to take scale, that is on x-axis 1 unit equals to 1 unit, 1 centimeter equals to 2 units, and y-axis 1 centimeter equals to 1 unit. So here starting here is 0, 2, 4, 6, 8, 10, 12, and here also -2, -4, -6, -8 and -10. At y-axis 1, 2, 3, 4, 5 and 6, and y-axis -1, -2, -3, -4, -5 and -6. Here these extreme points we have to denote in this graph. Here E of 10, 5, that means here this is x and this is y. So in x we have to denote here 10, and here y we have to denote 5. These two we have to intersect these 2 points here. Okay, and B of 6, 6, that is x is 6 here and y is 6 here. So we have to intersect these 2 points. Here C of 2, -2, that is 2, x is 2 and y is -2, that is we have to intersect these 2 points. And here D of 1, -0.5, x is 1, here is 1 and here is -0.5 is here. These are here we plot the graph here in the, it is the step 4, we plot the graph. In the step 5 we have to denote the intersect point. For example, extend these lines like this here and these lines like this here. Here this is intersect here, this is intersect, this intersect, this intersect, this is intersect. Intersect points are these are all. Here in the after the step 4 here we are denoted. In the step 7 we have to take here so many points we have. We don't know, we cannot take all these points at a time. These are how 1, 2, 3, 4, 5, 6, 7, 8. These are so many points here. We did not take these all points. So we check the we depending upon the constant condition we take the values. Here in the constant we have less than or equals to type now. So we take here nearer points. Here comparing here these points, here 0 to in x-axis which we have nearer point is this one, that is here denoted this is as P, that is P details P of 1, 0. Okay, this is nearer point. Here y-axis which is the near point to us from 0, comparing to 6, 2 and 5, we have 5, take it is as Q, we have Q of 0, 5, it is 1 point. And comparing to it is over and y-axis over, comparing to these 3 points, in this point which is nearer to us from this point, which is this is nearer, take it as R point. You have here R equals to 3, 1 point. Here R equals to 3, 1 point, and this is the point which is over here, and take this point as S point, which is nearer to us here from these 3. This is the nearer point. You have what value here? Here S equals to 5 comma 4. These are the intersect points. This is step 7. These are the intersect points. P of 1 comma 0 and Q of 0 comma 5, R of 3 comma 1 and S of 5 comma 4. These are the intersect points. Yes, so many intersect points are there. We cannot take all the points. To sort our problem, we take this help of constant condition. Here we have constant is less than type, so we take here nearer point. If here constant or greater than type, we take this point. We take the farther points. So our problem is within in only. Within in only we have our answer. So in the you can see here step 6 we have to take these points and obtain the intersect points. In step 7 we have to substitute the obtained points in the function z. So here z equals to, we have 2x1 plus x2. First of all, take point P of 1 comma 0, this point 1 comma 0. Substituting in this, we get z equals to 2 of 1 plus 0. Z equals to, we have value 2. And take q value, q of 0 comma 5. Substituting in this formula, we get z 2 of 0 plus 5, that is z equals to 5. Taking r 3 comma 1, substituting in z, we take 2 of 3 plus 1, we get z equals to 2 3 6 plus 1 7. And taking s of 5 comma 4, that is substituting in z, 2 of 5 plus 4, we get z equals to 14. This is the step 7. These obtained intersect points which are obtained from the graph, we have to substitute in z value. These are the z value. This z equals to 2, z equals to 5, z equals to 7 and z equals to 14 are the values. And in the step 8 we have to do that depending on the question. Your question is what? Determine maximum and minimum of z. So here maximum value of z is what? If we are asking maximum of z, if we want to determine maximum of z, we have to take the least value of z, that is z equals to 2 is the maximum of given objective function. 2 value is the maximum of given objective function. And here asking also for minimum of z. Minimum of z value is what? Z equals to 14 is the minimum of given objective function. It is a step 8. Again I am repeating. First of all, we have to write in the second step is objective function and constant. In second step we have to convert the inequalities of constant into equality type. And in the step 3 we have to extract the extreme point by placing 0 at x1 and again placing 0 at x2. We get some extreme point, that is like a of 10 comma 5 and b of 6 comma 6, c of 2 comma minus 2 and d of 1 comma minus 0.5. These extreme points we have to plot in graph like this. If we plot the points here like this, that is it is a, and it is b, it is c and it is d. By extending this plot denoted points, we get the sum full of intersect points. By depending on the constitution of constant, we take the points that is which are get like this: p of 1 comma 0, 0 comma 5, 3 comma 1 and 5 comma 4. These obtained intersect points we have to substitute in the z function in 7 step. And in the step 8, the z values which are came by substituting intersect point in z function, we have to take the maximum of and minimum of z by, we know that in the question. If we want maximum of z value, we have to take least value of z, that is like that z equals to 2 is the maximum of given objective function and minimum of given objective function is z equals to 14. Hope you like the video guys. Like, share, comment and subscribe and click the bell icon to be notified every update from my Small Studies YouTube channel. Thank you guys. Hello guys, welcome to my YouTube channel. Hope you people like the video. Keep supporting me by subscribing the YouTube channel and like, share, comment and click the bell icon to be notified every update from my Small Studies YouTube channel. Thank you guys.